The dir function is an absolute powerhouse in Python. See what it can do. Imagine we have a variable named name assigned to Robin. What happens when we run dir on it? Let's execute this and see. Look at that. The dir function instantly generates an elite list. It reveals every single built-in method, ready to interact with your specific variable. You can easily convert it to uppercase, change it to title case, or utilize, translate, strip, and starts with commands seamlessly. All these operations are right at your fingertips. It gives you a complete directory of available actions. You'll recognize many of these essential methods. But what happens if we leave dir completely empty? It dynamically prints out everything currently in active scope. Every single available variable and system method is displayed. Notice how our name variable appears right here in the list. It's automatically tracked just by calling dir, without any arguments. Incredibly efficient. This gets even better when you scan external modules. Pass the standard math module into dir, print the results, and look. We instantly get a breakdown of every mathematical function, pre-built right inside Python's core library. It even works beautifully on custom modules. Take a look at this custom analytics module I built. It's a straightforward Python file, and inside we have calculate revenue and highest sale. Those are two custom functions living in that file. Now watch this. We'll import analytics directly. Once imported, we're going to execute a print of our dir function to reveal the contents. With the module loaded, let's run dir on it. See the list. Scanning across the output, look closely at what's there. Both calculate revenue and highest sale are right there. Those custom functions live inside our Python file. Our module works perfectly. The functions we built earlier are perfectly populated in the output using the dir function, mapping everything inside that file seamlessly. It's the ultimate tool to discover available functions and track actions inside variables or modules. Remember, running it completely empty exposes the current scope of your program. That's exactly how it caught our name variable. It picked up analytics too. It lives right in the exact same directory as our active Jupyter Notebook script. Why should you alias your Python functions? Let's dive into a clear, practical example. The analytics file. It's sitting right here in our Explorer. Inside VS Code, you can see we have our dedicated analytics script. Py file. It currently contains just two functions. Calculate revenue, which sums up our data, and highest sale, which returns the maximum value. Now, let's import these directly into our notebook. We use the from keyword, then the module name, which, as you can see, is called analytics. That is the exact name we reference here. Next, we import the specific function we need. In this case, it's calculate revenue. Further down, we have our target variable defined, sales data. Now, let's compute total revenue. Running this block gives us a total of 6,050. A very straightforward example. So, why introduce aliasing into the mix? First, let's break down what aliasing actually means. Right now, we are referencing calculate revenue explicitly in both spots. The imported name perfectly matches how it's executed. Let's transform this using an alias, like this. Watch. By using the standard as keyword, we shorten it to CR. Notice the yellow line error? It warns us that calculate revenue is not defined. Python can't find that original name because it's been renamed. To fix this, we simply call our new alias, CR. Just like that, our function is successfully renamed. Let's quickly restart the kernel right over here. This clears out old variables for a fresh run. We'll let that finish up. Perfect. Our environment is ready. Let's execute this cell and then run the next one. Boom! We get our total sum using the alias. Now, imagine a scenario where you have two different modules, built with identical function names by different devs. To simulate this easily, let's clone our current module. We have a duplicate. Let's rename it, since spaces aren't allowed. We'll just add a clean underscore right here. There we go. The underscore is set. A valid module. We'll keep the function names exactly the same, but instead of computing a sum, we'll simply return the number 1 for both of these functions. For both sale and revenue. To check this, let's look at what's happening. Let's save this file, and it's good to go. Now, look at what happens in a scenario where we choose not to use an alias. We are importing calculate revenue from both sides. This time, we fetch it explicitly from our new copy module. Spot the massive issue here? Both analytics modules share the exact same calculate revenue function name. Earlier, we got our expected total, but what happens now? When we trigger this code, what will the output be? Let's run this cell and then execute the next. Wow, look at that. The output is just 1. This happens because the cloned module simply returns 1, whereas our original analytics module still calculates the proper sum. But here's the catch. Since we imported both into this notebook, the second import completely overwrites the first. The newly imported calculate revenue takes over. The absolute instant that line executes, we have an active naming conflict. In Python's world, the rule is simple. The last import wins. That's exactly why it outputs 1. It's driven by the copy module. But look at the magic when we alias it instead. We can tag the second one as calculate revenue copy, or simply CRC. Now when we rerun these cells consecutively, we get our correct output. Exactly as expected, drawing directly from our initial analytics module, rather than the second one, which we safely renamed. Now you can build setups like this. This line seamlessly triggers the isolated CRC function. And just like that, both independent functions coexist perfectly, one executing from the copy and the other from the primary module. And that is how you master aliasing in Python. In Python, you can easily centralize your common variables inside a single module. Right here, I'm working inside a Jupyter notebook. Take a look at this line, import settings. This settings file is our custom module. Opening up the File Explorer in VS Code, you will see that I have already created a dedicated file named settings.py. Let's open it up. As you can see, it contains just 2 simple global variables. Company name, set to HEC Corporation, and a tax rate of 0.2. Now, when you run import settings inside your main script, like this Jupyter notebook right here, it unlocks total access. We can instantly call settings.companyname and settings.taxrate. Let's execute this code. And just like that, there's our clean output. Want an even cleaner approach? We can use the elegant from syntax. Simply type from settings, import company name. This targets exactly what you need, bringing only that specific variable straight into your current workspace. Why is this a game changer? It establishes a single source of truth. Instead of repeating the company name or tax rate across multiple scripts, you can update it instantly in just one place, right here inside settings.py file, avoiding a massive headache later on. It is an absolute best practice to isolate shared configurations like this. By importing these predefined variables into your other development files, you guarantee perfect consistency across your app and completely eliminate typos. Leverage this powerful technique to manage your assets in a single module. Pull them into your workspace and access them easily using dot notation. Simply use the module name, dot, then your variable name, or switch over to the streamlined from syntax, extracting exactly the variable you need from that module instantly. Python actually lacks a built-in datetime data type. To work around this, we simply import an external module, since native date and time types don't exist here. Specifically from the core datetime module, we're going to import the powerful datetime class. This class unlocks some incredibly useful functionality. Let's see it in action. Once imported, we can call the super handy now method. This is a built-in method of the class, and calling it captures the exact current time. Running this code gives us 2026 as the current year, June as the month, and 8 as the day. The time uses a 24-hour clock showing 1:28 p.m., 12 seconds, 30 milliseconds, followed by microseconds, right at the end. Now, what if we only want to extract the current year? Let's see how easily we can target specific parts. We'll call that now method from the datetime module once more. With our current time safely stored away in a variable, we can type current time dot to reveal all the incredible properties available to us. As you scroll through this list, you'll spot the dedicated year property right there. Accessing it prints out 2026 perfectly. Let's duplicate that line and switch things up. What if we want the day instead? Using the day property gives us exactly that. We expect 8, and running it yields 8. Notice how it cleanly drops the leading 0. Next up, let's grab the month property. This should output the month of June. There it is, June represented as a 6. These are just a few of the attributes we can pull from the object. The now method generates a full datetime object that gets neatly stored inside this variable. From there, you can tap into any property you need. Python lacks a built-in datetime type. Instead, we import the powerful datetime class from its module. This class packs incredible tools, like fetching your system's current, exact date and time instantly. Running this code reveals today's date in 2026. It's June, specifically the 8th. That's June 8th, 2026, right at 2 p.m. But we can do so much more than just fetch the current time. We can actually build a custom datetime instance from scratch. Let's clear this out so you can see exactly how it works. It looks exactly the same, but we won't just invoke a standard function. Instead, we're diving into the class constructor. This constructor lets us pass custom values to build our object. Opening the parentheses reveals our available parameters. We can supply the year, month, day, hour, and beyond. First up is the year parameter. We'll set it to 2026. You can use any year, but let's stick with 2026 for now. Next is the month. We are choosing June. Notice that typing 06 will cause an error. Just pass it as a regular 6. Following that, we add the day. Pass it as 8, not 08. Now we see the option for hours. But notice that the default values are set to 0. So providing them is completely optional. Let's leave them as they are for a moment. Check out the output. Once executed, it perfectly displays the exact date we provided, June 8th, 2026. As expected, hours, minutes, and seconds defaulted to 0, but we can easily customize them. Let's set the hour to 14. Once added, it updates to 1400 hours. Now, what if we want to add 3 minutes? Remember, entering 03 isn't allowed. Just use a lone 3. There we go. But watch what happens if we push past 59 minutes. If you enter 60, Python throws an error right away. It clearly states, minute must be from 0 to 59. Python strictly validates that your input stays within bounds, so 60 is completely blocked. Let's use 59, and look at that, it works flawlessly at 1459. This gives us a fully customized datetime instance, built manually instead of relying on the standard now method. This is incredibly useful for tracking customer appointments, managing strict deadlines, or future subscriptions. The possibilities are endless. That is how easily you can craft custom datetime objects in Python. Just remember, Python lacks a native datetime data type. Instead, it relies entirely on the robust datetime module and class. Want to format dates and times in Python? When we run this default code, notice how Python displays the standard date and time layout. It lists the year, month, day, and exact time. But what if you need a completely different format? For instance, many regions prefer showing the day first, then the month, then the year. How? We use the powerful string format time method. This method accepts format codes like %d, %m, and %e. Let's copy this exact example into our workspace. Paste it right here and see it in action. Running this script gives us a beautifully clean output. Output 08, 06, 2026. How does this syntax actually work? Let's start at the beginning. If you pass a plain character, like the letter D, you might expect it to mean day. But notice it just prints the literal letter D. To trigger the formatting engine and unlock the built-in rules of the string format time method, you must prefix it with a %sign. The % symbol is the magic trigger for a special action. This dynamically transforms your date and time values. So by running %d, we instantly get 08. If we append another literal d, it just prints as text. But the moment we add a %sign, it repeats the day. Now, let's say we want to separate the day with a clean professional dash. Add it here. Run the code, and there's our dash exactly as planned. Get the month. Looking at our formatting options, the month code is M. Adding M right after the dash should do the trick. But remember, always include that crucial %sign. Without it, it just prints a literal M. But once we add the % symbol, watch the magic happen. It seamlessly converts to month 06. Case sensitivity matters. Look at lowercase m versus uppercase m. Highlighting uppercase M actually extracts the minutes. So using a capital M gives us 17 minutes instead. Since our target month is actually 06, we will quickly switch this back to lowercase m to retrieve the correct month value. Excellent. We have day and month ready. Now let's tackle the year. The year formatting utilizes the letter Y. Type in %y, and look at that, we get 26. Notice how a lowercase y delivers a sleek 2-digit year. Swap that to an uppercase Y, and boom, a full 4-digit year appears. Very useful. This is the precise syntax for mastering date and time layouts. You can take this control even further. Check out these extra features. We can seamlessly add hours, minutes, and seconds to day names. Just drop a % followed by the letter A. Using a capital A gives us the full weekday name, Monday. Switch to a lowercase a for the short abbreviation, MON. Capital A keeps it full and descriptive. Same logic applies to months. Capital B reveals the full month name, June. And a lowercase b yields the abbreviated version, Brilliant. Every Python developer and software engineer runs into this common need. You need to add a specific number of days to a given date. For example, a customer signs up today for a 30-day free trial, and you want it to expire in exactly 30 days. To handle this, we will import the Telbany class straight from the Datetime module. With this imported, we can easily grab the current time by calling datetime.now. But to add 30 days to that date, and open the parentheses. Look at the incredible options available here. You can easily pass days, seconds, milliseconds, minutes, or weeks, but you will quickly notice that there is absolutely no option for months or years. Why? Because months and years vary constantly in length. February might give you 28 days, while January has 31 and November has 30. Since these time periods are not fixed, you cannot use Telbany to add them directly. Instead, we stick to fixed units like days. Let's set days equal to 30. Boom, the expiration date dynamically jumps forward by exactly 30 days. Perfect. That is a perfectly precise measurement. Since we are in June, which has 30 days rather than 31, our timeline lands perfectly on the 8th of July. But what happens if we bump that up to 60 days? Will it land exactly on the 8th of August? Let's see. We run it with 60, and look at that. It gives us the 7th of August, not the 8th, because July packs 31 days. This gives you incredible control over intervals. Even better, you can stack them. Watch this. We can combine days and hours. Here is what's happening under the hood. Notice it doesn't store a fixed date or time. It purely tracks the specific duration or the precise time delta. Like 30 days in 1 hour. If we execute this, look right here. We have 30 days, and let's pass an extra 2 hours to the hours parameter. Where the timestamp originally read 1435, it now shifts to 1635. Let's run it. There it is, 1636, ticking forward slightly as we record this video. Just like that, we've combined multiple periods. The golden rule here is to stick with fixed, reliable time units. Our only exceptions are months and years, solely due to their natural variability. See, previously we saw that nothing variable. Days are always constant, just like seconds or weeks. But months are completely different. They vary. For instance, July always has 31 days, while September has exactly 30, and February shifts between 28 and 29 days. Telbany just cannot handle that. To solve this, Python features an incredible module called Dateutil. Inside Dateutil, we find relative delta. Think of it as the ultimate upgrade to the standard Telbany class. Let's look at our previous example where we pull the current time using the datetime class. We store that in a variable, and then we attempt to add 30 days. If today is June 8th, this shifts us to July 8th. It also adds 2 hours. Watch how the timestamp updates. If the initial time is 6:21, adding 2 hours beautifully advances it to 8:21. Now, let's unlock the power of Dateutil. The setup is identical. We capture the current time, but instead of Telbany, we deploy relative delta. This allows us to set months to 1 and hours to 2. Just like that, the months adjust perfectly. No more counting days. We are explicitly adding a month. This lands us exactly 1 month from today's date, completely handled by the smart logic inside relative delta. Hovering over the class reveals more. This tool builds upon the extensive datetime extensions originally developed by Lemberg. Though it features its own optimized algorithm, the documentation offers incredible insights to how it operates. But here is the core takeaway. Timbalata is strictly for fixed, unchanging durations. Use relative delta for dynamic ones. Now you know how to master the relative delta class, which lives right inside Python's powerful dateutil module, where days and hours never change with fixed weeks, but months and years are dynamic, shifting due to leap years and varying calendar lengths. Previously, we explored adding days as fixed time periods for datetime in Python. Remember, Python lacks a built-in datetime type, so it relies on external modules for this feature. By using time delta, you can easily add 30 days. Fixed intervals. Hovering over the time delta class reveals you can add days, minutes, or hours, but there is no concept of months or years. To solve this, Python provides a powerful tool inside the date utility module, relative delta. Why choose relative delta? Because it lets you seamlessly add months. Since months vary, they don't share the same number of days. February has 28 or 29 days. March 31. April 30. As you can see, every month is unique. That is exactly why we use relative delta. But watch out, if we add 1 month to the current time, it shifts the date to July, which is next month. Right now, it is June 8th at 1828. But notice it advanced the time by 2 hours, showing 8:28 instead of 6:28. The date changes perfectly to the 8th of July, moving forward from June 8th. The critical trap here is that if you accidentally use the wrong parameter, your results will break. Right now we are using the plural months, but if I switch it to the singular month, watch this. Instead of adding a month, it overrides and sets the month value directly to January. Change it to 2, and as you guessed, it sets it straight to February. February 8th. Always use the plural version to add time. To add 2 months, pass the plural argument months, which advances 2 months from today. But if we revert this to the singular month with a value of 1, it resets to January. Setting it to 12 will jump straight to December 8th, 2026. The exact same logic applies to hours. Set it to 2, and it overrides the time to 2:30 a.m. instead of adding 2 hours to the clock. Watch this closely. To explicitly set a month or a year, deploy the singular form without an S. No plural. To add a specific number of months, use the plural months. This cleanly adds 12 months to our current date, bringing us to June 8th. That wraps up this powerful feature, mastering time delta for fixed intervals and relative delta. For variable timelines like months and years will completely elevate your Python datetime handling. No more calculation bugs. See you in the next lesson to keep building your skills.